Final video, where we will be learning about applications of vectors in a mechanical context. In this example, we've been told that a particle of mass half a kilogram is acted upon by three forces, F1, F2 and F3, as to find the resultant force that acts upon the particle. So, the resultant force, as this diagram on the bottom right corner shows, is simply the sum of the three forces. So we are going to add the forces component-wise. That means components of i's will add up with each other, components of j will add up, and components of k will add up with each other. Let's do that. So this is the resultant vector, 5, 5i minus j minus 3k. We put the letter n for newtons because we are measuring forces here. Part of the question, we've been asked to find the acceleration of the particle. Now, using the Newtonian equation, F equals ma, force equals to the mass multiplied by acceleration. Now, here our force is the resultant force, capital R. So I should rather replace R with F. Now we know what value of R is, 5, minus 1, and minus 3. We know what the mass of the particle is. It's simply a half. Know the acceleration? No. But we can figure it out by multiplying both sides of this equation by 2. We will have 10 minus 2 and minus 6. So these are the components of the acceleration vector in I, j, and k directions, or rather x, y, and z directions. My writing off and look at the working out. In the next part of the question, we've been asked to find the magnitude of acceleration. So that simply means applying the Pythagorean theorem and finding the magnitude of the vector A. The magnitude turns out to be square root of 140. We put the letters m, s, minus 2 because meters per second squares is the unit measured for acceleration. We are using the standard units here, kilograms and newtons, therefore m and s are standing for meters and seconds. The next part of the question, we've been told that we are given the particle starts at rest. We are to find the distance traveled after 6 seconds of the motion of the particle. So we're going to dig into our Suvat equations and our mechanics knowledge. Suvat equations basically means that we are going to collect what's the distance, we don't know. Do we know the initial velocity of the particle? Yes, that's 0. Do we know the final velocity? Do we know acceleration? And do we know time? Yes, we do know time, and we are looking for velocity. We do know the magnitude of time. So, which equation is best to calculate distance? There are a variety of formulas. One of them is S equals to ut times half at squared. If you're not familiar with it, think about u is initial velocity plus at. If we integrate this formula with respect to t, we have is dv dt integration of u plus at with respect to t. Integral of velocity with respect to time will give us distance, and that is simply ut plus half a. That's the formula for distance. So we are going to substitute the values that we have up here and calculate the value for distance. We do know that 0 stands for initial velocity, as the question says rest. The particle starts at rest, therefore the assumption that u equals to 0 can be easily made. 0 times 6 is still 0. We're going to have half, and we're going to use the magnitude of acceleration 140, and 6 will need to be squared. Okay, so I'm going to use the PowerPoint for the answer, and we are going to get this answer that we know distance is found. We've been asked in the next part of the question to figure out what's the position vector of the particle from the origin after 6 seconds. Notice the similarity and difference between part E and D. Now we actually need to use the vector form of acceleration. What we need to do is use the same formula, but instead of using the magnitude of A, we are using the vector form of A. Once we do the calculations, it becomes 18. 18 times this vector will give us this vector. The other words that can also be used instead of position vector is displacement. If you were asked to calculate displacement of the particle, you would perform the same calculations that we just did. Okay, so I hope you found this video helpful, and I hope you do practice for the rest of the course, and I'll see you maybe in another video.